In GP, one of the common example that we can do is forming two simultaneous equations and solving it. But this time we have to solve it using the substitution method. Let's see. The third term of a GP, geometric series, is 18. So we can write U3 equals to 18. Now, you remember that the third term means A r to the power 2. So that is equals to 18. So this is equation 1. And the second information we have is the sixth term, U6, is 2 by 3. Again, you should remember it is A r to the power 5 and that is equals to 2 by 3 and this is equation 2. Now in question number A, what we have to do is find the common ratio. We have two simultaneous equations formed. That is what we have to do. First of all, two simultaneous equations formed. Now we cannot solve it by elimination, meaning cancelling one of the terms like we do when we have an arithmetic progression simultaneous equations. Here we have to use substitution. Since we have to find the common ratio, we can write A equals to A. So here A is equals to, we can write A is equals to 18 by r squared. So 18 by r squared, and here we have A equals to 2 by 3 r to the power 5. So we can write 2 by 3 r to the power 5. Now we have to solve this equation. We have to solve this equation to find the value of the common ratio. Let's do cross multiplication. We can bring all the r on one side. That would make it look like 18 r to the power 5 divided by r squared equals to 2 by 3. Then we can send the 18 to the other side and we can write r to the power 5 divided by r squared equals to 2 by 3 into 18. That means when we have r to the power 5 divided by r squared, by the indices rule, the exponent cancels off and it becomes 5 minus 2 or 3. And this becomes 2 ones are 2, 2 nines are 18, and this is going to be 27. Therefore, r cubed is 1 by 3 whole cubed. That means r is 1 by 3. We have found the value of r. R equals to 1 by 3. Question number B, we have to find the value of the first term. We can either put it here or we can put it in the second equation. So we can write when r equals to 1 by 3, A equals to 18 by r squared or 1 by 3 whole squared. That would be 18 divided by 1 by 9, or that would be 18 into 9, and that turns out to be 162. So in order to form the two simultaneous equations, I use the nth term of the geometric progression, which is un is a r to the power n minus 1, and after forming the two simultaneous equations, all I did was solve the simultaneous equation by the method of substitution. After this, there is going to be some other part to the question where we just plug in the value of the first term and the common ratio. So the first term is 162 and the common ratio is 1 by 3. So the next part, here we have to do find the sum to infinity. Now remember, the sum to infinity can only be found if it is a convergent geometric series or geometric sequence. Since the value of r is 1 by 3, meaning it is less than 1, so it is a convergent geometric series. So sum to infinity is a by 1 minus r. A is 162, we found it in the previous question, and r is 1 by 3. So 1 minus r is 1 minus 1 by 3. So the calculation turns out to be 243. Next, the sum of the first 10 terms is S10, and sum to infinity is S. They're giving the symbol S for sum to infinity. For some reason, in this particular question doesn't really matter. So we have to find the difference between the sum to infinity and the sum of 10 terms. So let's do question number D. First, since we already know sum to infinity, let's find the sum of 10 terms. Now, you have to remember that if it's a convergent series, then the sum of n terms is Sn, a multiplied by 1 minus r to the power n 1 minus r. That is the sum of n terms if it is a convergent series. So let's continue. So this is going to be a is 162 multiplied by 1 minus r is 1 by 3 to the power 10 divided by 1 minus r is 1 by 3. Let's first calculate this portion. 1 minus 1 by 3 is 2 by 3. So 162 divided by 2 by 3. So let's find that first. 162 divided by 2 by 3. That turns out to be 243. So this is going to be 243. 1 minus, now this is 1 by 3 whole to the power 10. So 1 by, so 3 to the power 10. So 3 to the power 10 is going to be, let me leave it to be 3 to the power 10. We can figure this out later on. So this is what it is. Now 243 is something like 3 to the power 5. Let me check here. 3 to the power 5 is 243. So if we multiply 3 to the power 5 with 1, that is 3 to the power 5, minus, if we multiply 3 to the power 5 into 1 by 3 to the power 10, it turns out to be 3 to the power 5 divided by 3 to the power 10. We have to use some indices here for this calculation. So this is going to be 3 to the power 5 minus 1 by 3 to the power 5, since this cancels off and we get 1 by 3 to the power 5. Now we have to find the difference. So the difference is going to be the sum to infinity, which is given by the symbol s, minus the sum of 10 terms, that should be equals to 243 minus 3 to the power 5 minus 1 by 3 to the power 5. Now since 243 is also 3 to the power 5, if we open the bracket, 3 to the power 5 minus 3 to the power 5 minus plus 1 by 3 to the power 5. Since this 3 to the power 5 and this 3 to the power 5 cancels off, and 3 to the power 5 is 243, so the value is going to be 243, and that's what they asked for. Show that s minus s10 is 1 by 243. Here again, we have to form two simultaneous equations and we have to solve it. The sum of the first and third terms. It is important to remember that in a GP, we cannot write down the sum of the n terms formula because there are two. If it is divergent, that means if the value of r has an absolute value more than 1, regardless of positive or negative, the sum of n terms is a into r to the power n minus 1 divided by r minus 1. On the other hand, if it is convergent, if the sum of n terms for value of r which is less than 1, meaning the absolute value is less than 1 regardless of plus or minus half 1 by 3, then the sum of n terms is going to be a 1 minus r to the power n 1 minus r. So in that case, so we have to use the sum of n terms. But here we don't know whether it is convergent or divergent. We don't have any idea about the values. And besides, we have individual term. The first term, which is u1, plus the third term is u3. Together they are 50. So we have to write them out individually. A plus ar squared is equals to 50. So this is equation 1. We cannot use the sum of the n terms because first of all, it is not sum of that many terms, and second of all, we don't know whether it is divergent or convergent. So whenever you do not know that, you have to add up the terms individually. Then the sum of the second and third terms, and u2 plus u3 is 30. That means ar plus ar squared is equals to 30. So now we have two simultaneous equations. Now we have to find the values of the common ratio. That means we have to solve the simultaneous equations by substitution method. What we can do here, we can take a common, and that turns out to be 1 plus r squared equals to 50. Therefore a equals to 50 divided by 1 plus r squared. Here if you take a common, it becomes r plus r squared equals to 30. Therefore we can write a equals to 30 divided by r plus r squared. So we have two expressions of a, so we can solve the equation like this. So 50 divided by 1 plus r squared equals to 30 divided by r plus r squared. So if we now cross multiply, it turns out to be 50r plus 50r squared equals to 30 plus 30r squared. If we bring all the terms on the left hand side, 50r squared minus 30r squared is 20r squared. plus 50r minus 30 equals to 0. Now, when we divide both sides with 10, it turns out to be 2r squared plus 5r minus 3 equals to 0. Now we can do middle term break. 2 3 is 6. So 2r squared plus 3r plus 2r minus 3 equals to 0. So if we take r common, it turns out to be 2r plus 3. And if we take 1 common, it turns out to be 2r minus 3. So obviously it doesn't go middle term break, because one is 2r plus 3 and the other one is 2r minus 3. So we have to try one more time. So let's cancel this and try another way of doing middle term break. So if 2 3s are 6, another way of getting this is 6 1s are 6. So 2r squared plus 6r minus r minus 3 equals to 0. We still get 6r minus r is 5r. So this time it is going to work. If we take 2r common, it will be r plus 3. And if we take 1 common, it would be r plus 3 equals to 0. And this is going to be r plus 3, and this is going to be 2r minus 1 equals to 0. Therefore, we know the value of r is minus 1, or we have the value of r is 1 by 2. You have noticed that we have two values of r. One, if you take the absolute value of 3, meaning the value of minus 3 without the plus or minus sign, then it is 3, meaning more than 1. So this is divergent. Here, if you take the absolute value of half, which is plus half, this is convergent. So we have found two values of r.